Hey there, it's Max again. This is BRISC number 3 from the 6th year of the Spokane Cyber Cup. At this point, you should have solved the first two. In the first challenge, you learned how to read BRISC instructions. In the second one, you learned how to go from the binary compiled version to the assembly. And now, we're going to read the assembly like we did in the first one, except that now we have inputs and it's a lot longer. So we'll read through the prompt. Now we know how BRISC works. What do you think you could execute to get the proper program? The imp instruction is used to get input from you. If you get the program to go to the next state block of code, not to exit via your input, you enter the proper character. The combination of all these inputs converted to ASCII will give you the flag. So at this point, the student should have an entirely disassembled program here. And what we mean by the inputs has to do with this block. So this is effectively a block for a single character of the flag. The imp instruction is going to take your user input a single character, or integer, doesn't really matter in this case, and put into memory address 5. And once it does that, it's going to do some operations on said values, and then it's going to compare that our input matches the result of these values. If it does match, then it will jump ahead over here. If it doesn't match, then it will exit. And that's the idea behind this. If you have the proper input, then you will go to the next step. And based upon that input, we can do this over and over again until we end the program. And the result of the input is the flag after if you add all of them together. So for instance, we'll do this one first. So we're storing 51 and 32 in 3 and 4 respectively. And then we are adding memory addresses 3 and 4 together. So this is going to be 51 plus 32. And if I do this in Python again, so we're do 51 plus 32. It's going to 83. Now, if we do 51 plus 33 and get 83, and we put the ASCII representation, which is going to be the number 83 in this case, we'll put that as the input, and as a result, we'll go to the next step. So what is this character, you ask? If you do CHR, we get a capital S, which makes perfect sense because the flag is going to start with SC6. Now, if we go to the next instruction, we can do the same thing again. We see an input in two numbers, and then it's going to do subtract memory address 1 with 33. So in this case, we want to do 171 minus 104, and that gives us the C. So you do this over and over again for each instruction here until you get the proper result. Now, I think there's enough instructions where it doesn't make sense to program. It just makes sense to do this by hand. And once you understand how the program works, then it becomes not too hard to get through this. The issue, though, is when you've actually done the binary to decompilation step incorrectly. And I'm guessing that students are going to have like one character they did wrong or something, and it's going to be bad. So I'm not 100% how we're going to deal with that. I'm hopeful that students will get stuff correct, but if there's a single character wrong, feel free to tell them, like, hey, I think this character is wrong. Go check these instructions now. That's just the complexity of having the challenges build off each other in this case. Cool. So to recap, we have a bunch of instructions that we need you to execute that were taken from the previous step. The input that the user provides needs to be truthful on this compare. If it's truthful on the compare, then it goes to the next step. Now that input, the integer value, converted to ASCII, is that part of the flag. And you want that part of the flag, or that part and add them together to get the actual flag. So hope this is a fun challenge. Great job to Josh, ex-student and a hardworking security professional. Thanks. Good luck in the next one.